Okay, up to here, okay, right? So we will study all these four types of the lattices. All these four types are under Bravais lattice. Okay, so primitive, body-centered, face-centered, and base-centered. So for body-centered, we normally write as I, the symbol. Face-centered, we write as F. Base-centered, we write as C. Primitive, write as P. Or for cubic, we just call it simple cubic. Up to here, okay, right? Okay, Okay, so there are several ways to choose the primitive access and the primitive cell, but the number of atoms in the primitive cell is always the same, which is 1. So for the primitive cell, there's always one lattice point, one basis. Okay, remember, it's a definition that you need to memorize it. For primitive cell, there's only one lattice point and one basis. Okay, you're going to use this knowledge again in the later chapter. Yeah, for your information, for solid state physics 1 and 2, all are interrelated. That means if you lost in the first chapter, then in chapter 2, 3, 4, you will get lost also. Okay, if you did not perform well in solid state physics 1, I can guarantee that you cannot perform well in the solid state physics 2 also, because even the solid state physics 2 is more to the property, but it still make use of the knowledge that you study from the solid state physics 1, especially the first few chapter. Okay, this is just for your reminder. So again, whenever I mention a primitive cell, then there's always one lattice point, one basis, and one atom for the specific case. So this is a lattice, okay? This is a lattice. The orange line, okay, lattice. There are many ways to draw the primitive cell, as long as the lattice point is 1, okay? So I can pick this as a lattice point, primitive cell. I can pick this as a primitive cell. I can pick this as a primitive cell. 1, 2, 3 are different primitive cell. Okay, the condition is that it only have one lattice point. How do I define that this only have one lattice point? Okay, so this is one lattice point, 2 lattice point, 3 lattice point, 4 lattice point. It should be 4 lattice point. What? Why I say one lattice point? What do you think? Because if lattice point here is shared with another 4 unit cell, 4 cell in 2D. In 3D, then the number will be 8. Can you imagine? In 3D, you will share with top 4 cell and bottom 4 cell. Okay, in 3D. But in 2D, it's only 4. Therefore, this lattice point only contribute 1 over 4. And then this lattice point contribute another 1 over 4. This lattice point contribute another 1 over 4. This another 1 over 4. So the total will be 1 over 4 times 4 equal to 1. So within this primitive cell, it only have one lattice point. Okay, same thing apply to this one lah. It's also 1 over 4 times 4. This one also, this part plus this part equal to half lattice point. This part plus this part, another half lattice point. So the total will be also 1 lattice point. As long as it has only one lattice point, then we can define it as a primitive cell. So 1, 2, 3 have the same area, and therefore they can consider as primitive cell. Okay, can I pick one as a primitive cell? Yes, because it only have one lattice point, and it fulfills the requirement of the Bravais lattice. Okay, all the basics are the same, and you can see that this point is equivalent to this point, same environment. So same environment, same basics, then it fulfills the Bravais lattice, so it can be considered as a primitive cell because it only have one lattice point. How about number 2? This environment, same with the other one, the next one, actually the same, right? So this one also the same. So whenever they have the same environment, then we can consider it as a Bravais lattice. And under the Bravais lattice, because it only have one lattice point, so this is a primitive cell. So next, unit cell. I think you heard I mention this term a few times, the unit cell. So what is the definition for the unit cell? The unit cell basically is the smallest component of the crystal, the group of atom, ions, or molecule, which when stacked together with pure translational repetition, it will reproduce the whole crystal. Okay, the unit cell can have one basics or more than one basics. It can have one lattice point or more than one lattice point, doesn't matter. Okay, unlike the primitive cell. For the primitive cell, there's always one lattice point and one basics. But for unit cell, doesn't matter. It can have more than one basic, can have more than one lattice point. Okay. So let's say this is the structure, then I pick this as the unit cell. Okay. So unit cell, the definition is that the smallest component. So from this crystal structure, of course, we can say that this is the smallest component, right? This is the smallest component. And then when they stack together, it can reproduce the whole structure. You can see that, okay, I have this unit cell, then when I stack together, I can reproduce the whole structure. So I can pick this as the unit cell. So again, the choice of unit cell is not unique. That means that you can choose any type of the unit cell as long as it's the smallest component of the crystal, and then when you stack it together, it can reproduce the whole structure. So like this case, I can choose this as a unit cell, so reproduce it. Okay. So or I don't like this as a unit cell, I can choose this as a unit cell, so I also can reproduce it. See that? When you stack it, you can reproduce the whole crystal. So we can define a unit cell. So in the exam, if I ask you what is the definition for a unit cell, so it's very simple. The smallest component of the crystal that when you go through the repetition, then it can reproduce the whole structure. That's it. Or you can just make it simple. The smallest component or the smallest cell of the crystal is also correct. Okay. So now I have one artificial example, sodium chloride. Let's say the orange one is a sodium, and then the blue one is a